certain protocols. For example, if you think about HTTP, that's over port 80. If you think about HTTPS, that's over port 443. There's a lot of different protocols, and there are 65,000 plus ports that can utilize these protocols. So everything related here has to do with these ports. Now, let's say that you want to connect to port 443 on a website. You're going to send out a SYN packet to that website. You're going to say, hey, I want to connect to you on port 443. And if 443 is open and available for connection, they're going to say, hey, you can go ahead and connect to me. And when you want to actually establish that connection, you're going to send that acknowledgement packet back. Now, let's make more sense of this. Let's go ahead and open up a tool called Wireshark. So this is built into Kali Linux. I'm just going to type in Wireshark, and I'm going to provide an ampersand here just so I have shell access if I need it in the background. And all I'm going to do is capture packet data. So this is going to be listening in on my NIC, and it's going to say, hey, what's he doing? Let's capture all that data. So we're going to capture that. I'm going to start a capture here. You're going to start to see a bunch of traffic coming through. You can see the different protocols here. You can see UDPs coming through right now. But we're going to go establish a TCP connection. So let's go out to the World Wide Web. And I've got Google up. I'm just going to refresh Google. You're going to see a lot of traffic start coming through. So I'm going to go ahead and just stop this right here. Look at all the data packets that get sent when you're using your computer. This is what's going on in the background. You don't even think about it. So we could see some synax there. Those are in the gray. Let's see if we could find a good one. Okay, so here is one right here. So what we're going to do, actually, let's find a better one. So we're going to come down to here, and we're going to say, okay, so here we are. We're our source IP. This is 192.168.57.139. We're going out to destination of 74.125.21.155. We're saying, hey, I've got this port here. I want to connect to your port. So port 443, this is a web page. We're sending a SYN packet. If that port is open and available for connection and communication, what's going to happen back is that IP address is going to say, hey, here I am. I'll allow you to connect on this port. And if we make that final connection, we're going to go ahead and send the ACK packet back, which is right here. It's going to say ACK. So that is the three-way handshake. Please do remember this is going to come back into play when we get into scanning, and we'll talk about stealth scanning and how we modify the three-way handshake to actually do some scanning. So that is it for this lesson. I will catch you over in the next one. All right, so before we go into the OSI model, I do want to talk about some common ports and protocols. Since this is a refresher, most of these should be pretty familiar to you. I'm going to run through them pretty quickly and just talk about them briefly on each of these common ports. And the reason I've listed these is because there are things that we'll see quite often as a penetration tester, and it's just something that as we're going through the course, if one of these show up, it's something that just rings a bell, and you see a scan, it comes back, and you see port 21, you just think, ah, yes, FTP. Or you see port 80, you think, ah, yes, HTTP. So you got to start training your mind to memorizing these ports. So when we get into our scanning, which again, we haven't covered scanning, but when we get there and we see what ports are open on a machine, we're going to be able to have these common ports memorized. So on the TCP side, we've got FTP. FTP is the file transfer protocol. You're going to see this in some assessments. You're going to see this a lot when we do something called capture the flag, where we run through some test machines. You'll see FTP open quite a bit. So FTP, file transfer protocol, all that means is we can log into this server, we can put a file, or we can get a file off the server. Now SSH and Telnet kind of play hand in hand. Telnet is the ability to log into a machine remotely. Now, SSH does the same thing. The only difference is SSH is the encrypted version of that. So with Telnet, you are in clear text, and with SSH, you are encrypted. Now, SMTP, POP3, and IMAP all relate to mail. We're not going to worry too much about mail in this course, but you might see it come back up at some point. So just remember your 25, 110, and 143. DNS. So DNS is a way to resolve IP addresses to names. And we could take a quick look at that if we go back to our Kali machine and say we're at Google here. We've got Google up, but the computer doesn't really know what Google is. The computer is just using nice text like google.com for us, the humans. What's going on the back end is Google actually resolves to an IP address. Now that IP address is how the computer knows to get back and forth. Because we don't want to sit there and type in IP addresses, this DNS or domain name system has been implemented for us. So we type in google.com. On the back end, it knows, hey, I want to go out to 179.10.22.34, whatever it is in reality. But this is just a quick way for the computer to relate to a human and the human to have easily readable access to some of this stuff. So going back to our PowerPoint, we have HTTP and HTTPS. That is a website, just what you saw there. Mostly everything is on 443 now, or HTTPS. The HTTP on port 80, you'll see sometimes. Remember, that is the non-secure version of the protocol. So HTTPS is encrypted, HTTP is not encrypted and not secure. So lastly, SMB ports 139 and 445. Originally, it was just 139. In the later versions of Windows, they've put on 445. You're going to see these ports a lot. This is probably the most common port you're going to see as a pen tester. These relate to file shares. You might also hear this called Samba. So there are a few names for it, but when you think of SMB and you see 139 or 445, think of file shares. And as a pen tester perspective, you got to think about all the crazy exploits we've had regarding SMB. The most recent one as of this course was the WannaCry virus, right? So you had the WannaCry virus. It's also known as Eternal Blue, was what it was built off of, or MS17010 was the official term of that exploit. That exploit utilized an SMB exploit to navigate through networks. So it became very vicious very quick because SMB is open so frequently on networks. Now, on the UDP side, we also have DNS over here. DNS is both a TCP and UDP protocol. We also have DHCP. Now, when it comes to IP addresses, DHCP associates you with an IP address kind of at random. Now, you could have the opposite of that is what is a static IP address. So with DHCP, you plug into your network, say your home network, and the internet just fires up. Guess what? Probably DHCP on the back end. It just picks a number between a range, says, hey, here's your IP address. I'm going to let you lease that out for 8 hours or a day or a week or however long the timing is set for, and that IP address is yours. Now, the opposite of that, again, is static. So you could say, hey, I want a static IP address, and anytime I plug in with this specific computer, go ahead and give it this IP address. So how are we going to know that? Most likely the MAC address, right? So from layer 2, it's going to know layer 3 and how to assign it. So again, DHCP should be pretty familiar to you. We've also got TFTP on port 69, which is the trivial FTP, and it utilizes UDP instead of TCP. And we also have SNMP, which is the Simple Network Management Protocol. So you will encounter SNMP occasionally on networks, not always, but when we do encounter it, there may be some information to be gathered, especially if there are strings being used that are community or public strings. And we'll worry about that when we encounter it, but you'll probably see it again in this course. So that is it in this video. We're going to go ahead and move on to the OSI model and tie all this together. Then we'll get into a little bit of subnetting, and we'll end this with a refresher on networking, a final video on networking. So I'll see you over in the next video. All right, so this whole time we've been talking about networking, and I've been throwing terms at you, and every time I throw a term at you, I try to use the respective layer for it. So you've heard me say layer 2, layer 3, layer 4, and those all correspond with what is called the OSI model. Now, if you're ever in a network interview, or if you're ever talking to somebody who has experience in networking, or even if you're on the help desk taking tickets, knowing the OSI model is incredibly helpful, and people will just throw layers at you, especially the people who have been in the field for quite some time, might just say layer 2 instead of a switch, or they might say layer 3 instead of a router. So I'm going to discuss the OSI model really quickly, give you a mnemonic on how to remember it, and just talk about some of the concepts within it and how to troubleshoot down it as well. So I picked this up from Keith Barker a long time ago. Great trainer, by the way. And this is the mnemonic. So we're going to go P, D, N, T, S, P, A. And this stands in my head for please do not throw sausage pizza away. Again, that is please do not throw sausage pizza away. So I'm going to put numbers corresponding to the layers in front of it here. And we're going to go ahead and type these out one by one. So on the first layer here, we've got what is called the physical layer. And you could think of your physical layer as like data cables or like your Cat6 cables, stuff like that. Something you might plug in, right? That is the physical layer. And we've already talked about layer 2 quite a bit. Layer 2 is the data layer, and that is our switching, right? And also our MAC addresses. Going down the list, we've got the network layer, which is IP addresses. Also routing. The fourth layer is the transport layer, which is TCP, UDP, which we have talked about as well. And the last few, so the session layer. We've got the session layer, which is just session management. You don't really have to worry too much about this one. 6 is the presentation layer. Now, this should be familiar to you because think about WMV, JPEG, movie files. That's what your presentation layer is, so media. And then lastly, we've got the application layer, which is like HTTP, SMTP, your applications that you utilize, right? So we've got this laid out here, and you might be asking, why is this important? Well, again, when we say something like, my home router is a layer 2-3, so that means it does switching and it does routing, right? You might think of this in another way as well. You might be asked to troubleshoot. And something to talk about too with the OSI model is when we receive data down this physical layer all the way down to the application. When we transmit data, it goes out the application layer down to the physical. When we're troubleshooting this, it is always best to start with the physical and go down to the application level. Okay, so say you're working help desk and you get a phone call and somebody says, my internet's not working, help me. Well, what's the first thing you're going to do? Are you going to ask them application level questions? Yeah, probably not. You might say, hey, can you look at the back of the computer? Do you see the cable plugged in? Oh, the cable's plugged in. Okay, well, do you see the where the cable's plugged in? Is there a blinking light? Is that blinking light green by chance? Okay, we're checking the NIC, right? And then we might ask them to, do they have an IP address? What's going on? All the way down. And then we troubleshoot all the way down to layer 7. So we wouldn't start on layer 7, right? We would start from the basics and move down. So it's important to know this. This isn't a help desk course by any means, but it's super important to know this, especially if it's been a while since you've seen this network stuff, or even if this is new to you, that the OSI model is commonly referred to. Even as a pen tester, I get all kinds of layer 2, layer 3 talk, and you will be sitting in meetings with network engineers, with people who are very, very smart about this stuff, and they're going to throw all this lingo at you. So if you know this lingo, really, really benefits you, or else you're just going to sit there and wonder what the heck they're talking about. So hopefully this is a quick, informative method for you. And again, remember, please do not throw sausage pizza away. That's the easiest way that I remember it. You can make up your own mnemonics if you want. People have other things as well. If you've got a favorite mnemonic, please feel free to comment down below and tell me your mnemonic as well. So I'd love to hear some of these other ones. So let's go ahead and move on into subnetting, and then we'll start moving into other fun parts of the course. Let's talk about subnetting. So subnetting is important in networking. You hear about it all the time. You hear even people perhaps freaking out. I know I freaked out when I heard that I had to do it for exams like Network Plus or CCNA. And I feel like there are a lot of complicated methods out there for subnetting, but there was a method that was shown to me middle of my career and it just blew my mind. It's really, really fast subnetting method. And I really want to break down for you what subnetting is, why we do it, and then show you the methodology behind it. So if we want to talk about subnetting, if we just come in here and just do an ifconfig, and we look at our IP address, right? We have our inet, which is our IPv4. And you can see here too, we have this net mask. This is also known as a subnet mask or a subnet. And it just says 255.255.255.0. Doesn't really tell us a lot if we don't know much about it, but this is what a subnet looks like. And we can think of subnets in ones and zeros. It's all bits, right? So we've got 8 bits here, just like an IP address, IPv4, same thing. 8 bits, 8 bits, 8 bits, and another 8 bits. And we've got ones and zeros. If all the ones are switched on, we've got 255. If none of the ones are switched on, we've got 0. And depending on how those ones and zeros are switched on or off determines a lot of things for us. And that's why this net mask is important. Now, attached to your resources for this course, I've created an Excel sheet that I think will be useful. So if we look at the Excel sheet, here is the CyberMentors subnetting sheet. And let's talk through this. It looks like a bunch of numbers and it might look crazy for you. And we're going to talk about how this breaks down, how the bits break down, and then how I would write this shorthanded for an exam or a test or just something that I do on a day-to-day basis. So first, let's talk about the bits. So come to the bits tab here, and we have our 8 bits, right? We can count this across, and there's 8 here on the count, and you can see that. And it starts with 128 and descends down to 1. You just keep cutting it in half, right? So 128, 64, 32, 16, 8, whatever. What's more important is why we get to these numbers. So if we have a 1 switched on here, it adds to the value. When all the ones are switched on, it equals to 255. You see all the ones switched on here. If we were to highlight over all this, come down to the sum, you see the sum is 255. That's all this formula is doing here. So if we were to come through and you see all the zeros here, nothing's flipped on to actually turn any value on here. How this actually works is the switch has to be on in order, right? So if we were to switch on another bit, we'd have to switch it on here. And we'd have to switch another one on here. We couldn't just come down here and switch it on here. It wouldn't make sense. It doesn't work that way, not with subnetting. So we're going to take these back off and just show zeros again. But you see how the values change. If, for example, we had this network and you saw the default, and I'm showing you the 255, 255, 2550, this standard here, because that is what's known as a /24 network. That's very, very common. And it's very common because it's used mostly in households and small businesses. And it's done this way because of the amount of hosts that it allows. Now, if we talk about the host, you can see that I have here 2 to the 8th power. Why do I have that? Well, we actually go by how many bits are switched off or how many hosts are available to us. So if a host here or a bit was switched on, then we lose the amount of hosts we have available to us. And this subnet gets smaller and smaller. Now, don't worry too much about the ones and zeros. It's going to make a lot more sense when we stop talking in these binary terms. I just kind of want to break down the math behind it first before we make it really, really simplistic. So again, we're talking about what's called this /24 or WAC24 network. And it's so standard because of the host. Again, 256. Think of all the devices in your house. You have cell phones, you probably have computers, you might have like a Roku or Amazon Fire or something along those lines. You might have smart TVs or smart watches or something that connects to the internet. Well, again, they're all connecting through NAT, right, and going out, but the amount of hosts that you can have on your private network really depends on this subnet mask and how you set it. So we have this class C that you saw before, the 192.168.1 or .0 or however you want to have it, right? Well, it allows us to have 256 when we have a subnet of /24. So that's very common for a household. It's also common for a small business. Maybe there's a printer, some few devices in there, but they're never going to get over this 256 hosts. Okay, so when we come to the subnet cheat sheet, let's break this down a little bit differently. So we have our host here. Let's start with the /24 where we just were. And you saw that there is 256 available hosts as we start turning off bits. Okay, we turn off a bit here, we turn off a bit, keep going down the list. The hosts start getting bigger, and that just corresponds here. We have a /24, and the only reason I'm saying 24 is I'm counting the ones across, right? So we got 24 bits switched on. If we had 23, okay, it gets bigger and bigger and bigger. Now, let's stay away from the ones and zeros. I think it's a little bit complicated. The better way to think about this is to look at the subnet mask down here. And I'm going to replicate this, and then we're going to come back to it. So what I do here is we can have a possibility of 32 bits switched on, right? So I'm just making a new tab, and I'm just going to go over here, and I'm going to hit Control and drag this across till it hits 8. Okay, and then I'm going to do the same thing with 9. I'm going to drag it across. All I'm doing is just making, really quickly, 32 placeholders. And I'm just emulating here if we had the possibility of 32 different switched on bits. So imagine one bit is switched on, imagine all 32 bits are switched on. That's the possibilities here, right? So always, for sure, we're going to have an amount of hosts, and we're going to have a subnet mask, okay? So we'll just call it subnet there. We always start here with 128, just like the bits that you saw. You saw the 128 start on the bits. Let's just start also with 128. Now, as you saw, every bit that's switched on, remember when we switch a bit on over here, it starts decreasing. So we're going to decrease for the bits that are switched on. 64, 32, 16, 8, 4, 2, 1. You come over here, and what I like to actually do is I like to just add these numbers together. And you can see 128 and 64 is 192. And then you can add these two together. So you get 192, 32. You just add diagonally is the way I actually always do it. So 224, 240, 248, 252, 254, and 255. Now, what does that correspond to? It corresponds to the possibilities of the bits being flipped on, right? So this looks just like what you see here. Same deal. And if you had a 1 underneath of it, okay, then you got 128. If you've got another 1 underneath of it, well, guess what? You've got 128 plus 64, which is 192. And this number keeps growing. Why is this important? This is still all ones and zeros, right? Well, let's start thinking about it. If we have a /24 network, we've got 24 bits turned on. Our subnet mask is 255.255.255.0. If we had a /16, it becomes 255.255.0.0. Why? Where are these changes coming from? Let me show you this. Okay, for a /8, I'm just tying this into just this right here. Well, this is coming from the number of bits that are turned on. 8 bits turned on, we've got 255, and the rest are zeros. You got another 8 bits turned on, 255, 255, the rest are zeros. Come down to this /24, which is that really common subnet that you see, and you've got 255, 255, 255, 0. Now, this is very common, okay? Let's go back to the cheat sheet now. And you can see that I've got X as a placeholder in the subnet. So what I'm saying here is you look at this list and you say, I've got a /1. Well, for this whole area here from 1 to 8, the placeholder is going to hold in place of this X. So for a /1, if I've got 128, then guess what? It's going to become 128.0.0.0 because that's how it would be. And if you turned on just one bit here and made all of these zeros, guess what? Just the 128 would be on, the rest would be zeros. Okay, if we had a /14, okay, so 255's automatically flipped on. You have a /8 already, you passed through it. Okay, so you're starting on the second iteration here. /14 corresponds down here to 252. So you'd have a 255.252.0.0. So all this is placeholders. Let's go back to the sheet here. So I make this quick and dirty list. This is what I write out when I'm just writing out something quick for an exam. I'll write out 1 through 32. I'll put the host here and I'll put the subnet here. So again, if we know that once we cross through 8, 16, 24, 32, that has a 255 in front of it, all we've got to do then is we'll say /27. Well, we've come through 3 columns. Then I know for sure that we've got 255.255.255. something, right? You see the /27, you come down here, the subnet would be 224. Say 28. Okay, 255, 255, 255. Look at the 28, you've got a .240. And this is going to be confusing. Subnetting is not necessarily easy. Once you get the chart down, it makes a lot more sense. So let's start piecing some more things together. When I say that I've got host, now the hosts that I'm showing you only correspond to these first rows, but it's very common or very useful just to know this number right off the bat. Now, if you look at the cheat sheet, what you can do here is you just know that you start with a 1 or you start with the 128 and you go down, but every time you go up, you're doubling. And why are we doubling? Do you remember from the bits part? Every time a bit is turned off, so as we go up a number, we take it to the next power. So we've got 8 bits turned off, we take 2 to the 8th power, it's 256. Well, here you go. Look, come through here, 256, we go to the 9th power, 512, to the 10th power, 1024. It just keeps doubling, okay? That's all you got to think about in your mind, is it keeps doubling. So on an exam, for example, you might have something like, how many hosts could be potentially in a /20 network? And you come to your cheat sheet that you made or you have in your head and you say, well, 496, and then we'll get to this in a minute, but we have to subtract 2. So 494 potential. And why is this all important? What do we even care about any of this? Why am I rambling on? Well, you need to know based on the network. Okay, the /24 is great for a small office, home network, however you want to have it. But what if you're a large enterprise? Maybe you have thousands of devices, okay? Maybe you want a /16 network. That might make more sense for you. Or you even see some with a /8 network. It just depends on how big the company is. The larger the company, the greater chance that you're going to see that they're not using /24. Or they could even have subnetted segments of their network where, say, they have just telephones and they've got 500 employees and 500 telephones. They might just have one /23 network for nothing but telephones because that's the amount of hosts that fit in there. So what we're after with subnetting is how many hosts can we fit and what is the mask that's behind it? So those are questions you might be asked in an exam, and these are questions that you're just going to see. And when you're given addresses, say you're doing a pen test for a client, you might be given something like this. You might be given an IP address, 192.168.1.0/24. Okay, and immediately in your head, you're like, oh, /24, that's standard. There could be up to 256 hosts or 254 hosts or devices in this network. But if they gave you something like 192.168.1.0/20, then you might look at your little chart and say 4,094 hosts. Remember, we're going to subtract 2. 4,094 hosts in this network. Now I know if I'm scanning this, I'm up against a lot more devices potentially than I am in this. Okay, so when a client gives you your subnets, they might just write it out like this. And depending how big your client is, might depend on how big their subnets are for you. For example, I just pen tested a client that was a /16 all the way across. And it looks something like 10.1.0.0/16. Okay, and your subnet mask for that would be something like 255.255.0.0. And how does this come into play? Well, every time you have a 255, that number's locked in place. That's another way to think about this. So that 10 is always locked down. This 1 is always locked down. The rest of the bits are fair game. Meaning we could have 10.1.1.0.1.2.3. We could actually have a 0 here. 0.1.2.3.4. And that's how this number for like a /16 gets so big, because you have 10.1.0.0 through 255 on the possibilities, which equals 256 hosts. Okay, for one range, you get 256. Well, imagine you have to do that 255 other times, right? And that number gets substantially bigger here. And then if you were to have a /8, then of course it gets bigger and bigger. So what you need to realize are a few things here. We have these addresses, and you see the /1, /8. Again, we call them WACs. WAC 24 is going to be very common. I would say WAC 16 is probably your next common. You might see some weird subnetted networks like this, but typically it's /24, /16. Now, your network ID is typically what is known as your first address, and your broadcast ID is known as your last address. This is not always the case, but it is very common. And let me log back into this Kali machine here and I'll show you. So we have our IP address, 192.168.57.139. And we've got a net mask of 255.255.255.0. What does that tell you from what we just learned? That tells you we have a /24 network. Okay, this is a common network. There are potentially 254 hosts. Why do I keep saying that? Why do I keep subtracting 2? Well, we've got a network ID and a broadcast ID, or broadcast IP here. Well, what we need to know is we are .139. We could be anywhere from .1 to .254 within this network. That's our 254 possibilities. This 0 means we have the flexibility to be any IP address range from 1 to 254. Usually a .0 for this IP here and a .255 make up your network ID and your broadcast IP, okay, usually. So if we were to say something along the lines of, let's go back to this Excel document, and we were to say something along the lines of this. Let's say that we have a /24 network, and we want to know how many hosts, we want to know what our network ID is, and what our broadcast ID is, or IP is, okay? We would say, okay, and we'll give it one more. We'll say it's a /24, and the IP starts with 192.168.1.0, okay? Or we can even write it like this, 192.168.1.0/24, delete this, and we'll say, what's our subnet mask? What's our host? What's our network? What's our broadcast? So subnet, you come to your cheat sheet, you say, okay, /24, I already know that I need to be filling in this area here on the X, so I'm just gonna come in 255, what's the X? Well, we know to come down this row, 255 here, .0. Okay, and then we've got hosts, so I'm just gonna expand this a little bit. We've got the hosts, okay, hosts are right here, 256 hosts. Potentially 254 though, because we always subtract 2 from the host total. So our network ID is usually the first address available to us, which is 192.168.1.0. The broadcast is 192.168.1.255, meaning available to us is anything from .1 to .254. Let's take a look at something else. That's a basic example. Let's do like a /28. Let's say we got 192.168.1.0/28. Now what? Well, we've got 16 hosts here. Okay, so our subnet is then going to fill in 255.255.255.x, right? Because we're in this row. /28 says it's going to be a 240 when we drop down to the subnet mask. I'm going to make this a little bigger. How many hosts? 16 minus 2. We have 14 hosts. Okay, so the first non-host would be 192.168.1.0. Again, still the same thing. First address. Last address is going to be what? 192.168.1.15. Does that make sense? 0 to 15 is 16 addresses. Usable space is 14 because we take out the network and the broadcast. Now, you could see something like this, and then guess what? You're segmented. So because you're only using this little bit of space, you can then in turn have something like this, 192.168.1.16/28. And then it starts the same way. Your subnet mask is actually the same because you're using a /28. You come through, you can just copy and paste that. The hosts are still the same. What changes here? Well, your first address, 192.168.1.16, and then your last address, which is 192.168.1.31. So because this is smaller on the /28 side, we can actually have multiple networks within, like, say, a .1, .0, .1, .16, .1, .32. You get multiple little networks here with only a small amount of hosts. So maybe you have just a few servers in this range, and you have like servers A, B, and C. They go in a /28, and then you have another one of servers D, C, and E, or D, E, and F, however you want to say it. And you have more in that range. Okay, so you can subnet this out into different things. And when we see subnets, we see all kinds of stuff. We could see phones, servers, user computers, wireless, all different sort of things. Some companies get really specific with their subnetting. Now let's try one more. Let's say we have a /23. Now I want to put in 192.168.1.0/23, but that would be wrong. Why would this be wrong? This is actually going to be a 0, and I'll show you why in a second. So we're no longer locking in this number anymore, right? When we get below the /24, the 255 all the way across for 3 of them, guess what? We're now have the ability to change this number other than what's locked in. So let's do a .0. We'll talk about why. Let's hit enter here. So a subnet on a /23. Well, we're going to do a 254, which is going to be the placeholder of the X here. We're going to come in and say 255, 255, 254.0. And now again, we're not locked in. So remember, this 255 would lock in this .1. That doesn't happen anymore. So we've got 255, 255, 254.0. We're actually going to start at 0 here. And we're going to say the number of hosts that are possible, it's 510. Okay, 512 minus 2. We'll say our network ID is 192.168.0.0. And our broadcast would then be 192.168.1.255. Why? Okay, so we have the possibility now that we're spanning 2 ranges. We've got 510 hosts in this network. Okay, and we have the ability to go between 0 and 1. We've got 2 options now, 0 and 1. So if we were to say another network, if we wanted to get to like a 2, we'd actually have to say 192.168.2.0/23. It would be the same subnet mask, same number of hosts, but then this would be 192.168.2.0, 192.168.3.255. Again, there's 510 possible hosts in between this, right? Because you got to think, .0.1, .0.2, .0.3, all the way through 254. And again, 1.1, 1.2, all the way through 254. So that equals 510. Once you've hit that maximum, that 1.255, then guess what? You start at 2, you have a whole new network here. Just like these smaller segments, you get whole new networks on the bigger side as well. So what you need to know is that if I were to put something like a 192.168.1.0/23, that would have fallen into line with the 1 and the 0, and our actual network ID still would have been 0.0, and a 1.255 would have been the broadcast here. And you can double check this. Anytime you're confused, you can double check your CIDR notation. So I'm going to bring over a website that I will show you here. And this is just an IP addressing guide. It's called ipaddressguide.com. You bring this over and you scroll down just a little bit, and I just put in 192.168.1.0/23, and you can see that it actually corrects me and says the first bit is 192.168.0.0, the last one's 192.168.1.255. Total host is 512 minus 2. Shows you that, again, first IP, last IP, you got your net mask. Very easy to use a CIDR calculator here, or an IP range to convert to CIDR as well. So very useful calculators, but if you're not allowed to use these for like an exam purpose or something along those lines, then using the cheat sheet that I've shown you is super useful. Now, what I want to do is I want to try 3 more subnets. Okay, I'm going to write these out. I'm going to say 192.168.0.0/22, 192.168.1.0/26, and 192.168.1.0/27. I want you to solve these for me. Tell me the subnet mask, the host, network, and broadcast. And with that being said, this again is a very complicated topic. I did not pick this up the first time or the second time that I got it. If you're running confused right now, perfectly normal. You can go back and watch this video again, try to pick up more topics, try to understand it. Maybe I'm not the right instructor for this either. I do recommend looking at other resources to completely fill in your knowledge gap if there is one that exists. Another resource that I'll link down is what is called 7-second subnetting. It is very useful. A lot of students have recommended it to me. I'm going to push it forward as well. So go ahead and try to solve this. Understand that what you're after here is just understanding what a subnet is. Okay, when you see something like this, if a client sends you 192.168.1.0/24, you're going to say, hey, okay, I know that there's probably 254 hosts in that network, and I know what I'm working with. If you see this 255.255.255.0, again, you know that you're working with a /24 network. Very standard stuff. That's what we're after. I don't expect you to ever memorize this. I don't have this memorized. Like, I don't come in here and say, you know, a /18 is a 255.255.192.0 network, and it's got 16,384 hosts. I don't do that. Okay, I have a cheat sheet. I'll use a website if I need to. For the most part, what you need to understand is 254 hosts for a /24. If that number has gone up to like a /28, you know you're dealing with less. If that number is lower, like a /16, you know you're dealing with a bigger network. That's really what it comes down to, unless you are working in networking, and then these become more important. But as a pen tester, understanding how to read this, understanding what the subnet is, and just identifying it with very basic measures, this is extremely useful. So I will catch you over in the next video when we talk about solving these challenges, and hopefully we got them all right. So I'll see you over there in the next one. All right, so let's solve this challenge together, shall we? We've got a 192.168.0.0/22. Why did I write this out this way? Well, similar to the /23. So if we come to a /22, we see that there are 1,024 hosts, which means we have a possibility of 1,022, right? And all we need to do is fill in the blank on the X. So 255.255.252.0. We come across, we know our first IP here, or ID, is 192.168.0.0, first address possible. Now, if we think about this, we can kind of do this mentally in our head. We can think, okay, there's probably 250 or so hosts in a network, and we've got 1,000 or so hosts here. Well, that's going to be about 4, right? 4 ranges, because we've got 1,000 divided by 250. So I'm going to go ahead and go 0, 1, 2, 3. That's 4 total. We'd say 192.168.3.255. And hopefully that math makes sense. Again, 0.0.1 through 254, .1.1 through 254, .2.1 through 254, .3.1 through 254. That equals about 1,022 hosts. Okay, actually, I lied to you. The only two we're taking off are 0 and 255. You actually have .0 through 255, 1.0 through 255, all the way. We're only subtracting these two. So if you do that math, that will add up to 1022. Okay, so a /26, we've got a 255.255.255.192. Fill in the blanks, fill in the X's. 64 hosts, well, we got 62 in reality. And we're gonna say 192.168.1.0 and 192.168.1.63. Again, if we wanted to create a second network, we could start here with a 64/26, and we would start with 64 as the network ID, and then 127 as the broadcast. And lastly, 255.255.255.224 for a /27. We've got 30 potential hosts because we got 32 minus 2, 192.168.1.0, and then we're going to do 192.168.1.31. Same thing here. If we wanted to create a second network, we could. We could say 192.168.1.32/27, and then this would start at 32, and this one would end at 63. We can make however many networks within that, 4 to 8, I think 8 different segmented networks with the /27. So that is it. Again, as I said last video, this can be confusing. And all we're taking away here is identifying what the CIDR notation looks like, identifying the base that to me is /24 being the most common, what you'll see, understanding what a subnet mask is and why it's important, especially in relation to hosts and the number of devices that you can have on a network, and why you might see something like a /28 or a /23, or more commonly something like a /16. So understand again that /24, as you see a bigger number there, or you see even, something other than 3 255s in a row, understand that the number of hosts are getting smaller. The less 255s you see on your screen, the number is getting bigger for the number of hosts. Okay, and just understand how to read this. That's all you need to take away. Again, I'm going to provide additional resources as I provided in the last video. Go review them. If you don't understand them, you can always come to the Discord channel. You can always ask Q&A questions. This is not an easy topic to pick up, but it is a topic that I had to show you as part of networking. All right, so in order to be successful in this course, we are going to be utilizing what is called a virtual machine. Now, virtual machines are known as VMs for short, and a VM is just a machine on top of a machine. And to give you an example, I'm actually running this Windows 10 instance that you see here on top of my Windows 10 instance. So here you can see, if I scroll up, that I have a Windows 10 machine. I also have a Linux machine sitting here. If I were to demaximize this, you can see that I'm actually running here a Windows machine in the back. This is my wife and I, and you come through here, we just blow it back up, and we're back inside of our machine. So a virtual machine is just a machine inside of a machine. So what we're going to be doing is we're going to be utilizing this to build out labs. That way we don't have to actually have a bunch of hardware. We can just use this for our course and run what we need to on top of our own machine already. Now, this can get resource intensive. So if you are only utilizing something like 8 gigabytes of RAM, then you might have some issues with this, but you can still follow along. When we get into the Active Directory portion, you might run into issues if you do not have at least 16 gigabytes of RAM to utilize. But we'll worry about that when we get there. There are still plenty of ways to follow along throughout this whole course. So another thing to note is that I use VMs every single day. This machine that you see here is actually my day-to-day pen testing machine. So I run a Kali Linux instance on top of my Windows machine and utilize that to do penetration testing. So I'm going to demonstrate that to you and how we're going to build out our labs with that. And a lot of us in the industry run through VMs as opposed to running it directly on Metal or on a machine. So in order to utilize virtual machines, we first need some sort of virtual machine software to play these. So there are two different ways that we can do this. If you are on a Windows machine or a Linux machine, you can utilize VMware Workstation Player. Now, if you type in VMware Workstation Player in Google, the first one here that says download VMware Workstation Player, you just click on that. And if you are in a Mac environment, you're going to be utilizing Oracle VirtualBox. So if you type in Oracle VirtualBox, you come here and you go to Downloads. You have your option there as well. So in this course, I will be using VMware Workstation Player. I'm going to be running it on top of Windows. If you are using Mac, that is absolutely fine. You're going to be following along just the same. All you need to be able to do is follow the same instructions that I give you, and you will be A-OK. So if you scroll down here, you can see try Workstation Player for Windows or try Workstation Player for Linux. Go ahead and just select Download Now. That should bring up a download, and go ahead and save it. If you're doing VirtualBox, go ahead and download for OS X. I will download the Windows version just so that we can see what that looks like as well. So I'll save both of these. So let's view our downloads, and we've got VMware Workstation Player here. I'm going to go ahead and open this one, and we're going to install this. And this will be very point and click. So next, accept the agreement, possibly give away our first child. Yeah, we should go ahead and install the enhanced keyboard driver while we have this. And then we don't need to join any improvement programs or check for product update. That's okay. We will install desktop, start menu. You check your preferences as you like it. I'm just going to install this, and this should just finish here in just a second. Okay, then you'll be brought to this screen once everything's done. It should take about a minute or two, and we're going to go ahead and hit finish. And it's going to want a restart to take effect. You can go ahead and restart your system. I'm going to say no right now. Let's go ahead and install VirtualBox if you are a Mac user. We'll hit next. Next here. Next, and yes, and install. Accept. And again, very point and click with the installation. Select install and any options that do pop up. And then we can start Oracle VM if we want. Let's go ahead and just start that. This is what Oracle VM looks like. And let's see if we can start the VMware player here, even though we need a restart. And this is what VMware Workstation Player looks like. So here you can see that we have virtual machines. We can create new virtual machines, open ones, etc. We'll get into that in the next video. So again, if you are using Windows or Linux, this is probably what your view is going to look like for the rest of the time. If you are using Oracle on a Mac, this is what your view is going to look like. Another side pro tip here is that I am using Workstation Pro, and I might utilize this in some instances throughout the course. Other instances, I'll be utilizing the Workstation Player. They are not much of a difference, especially in the beginning. When we get into the Active Directory portion, it might actually be worth it for you all to download the VMware Pro trial, because the trial is 30 days and you can utilize that to get through some sections and actually have nice little windows here to be clean and just have a pro edition. You can do everything that I'm going to show you in the course on the player. It just is that you have to open, if you want to run more than one machine, you'll just have to reopen the VMware Workstation Player several times to run multiple machines, but that's okay. It just won't look like this nice clean layout where you can transfer between machines like I can do just here. So with that being said, let's go ahead and move on to the next video. We're going to be installing Kali Linux onto our VMware Workstation Player. Now that we've installed VMware or VirtualBox, we need to install Linux. We're going to be using a version of Linux called Kali Linux throughout this course. This version of Linux is a Debian-based distribution which is geared towards ethical hacking and penetration testing. So it's a special version of Linux that allows us to have all the tools in one place that will allow us to hack without having to download these tools and install them on our own custom Linux distribution. So it's all kind of nicely built into one package. So if you go out to Google and you type in Kali Linux download, you should see this link. I'll put the link in the description below as well, but you should just be able to go to Get Kali right here. And you're going to be presented with a couple of options here. We're going to be using a virtual machine in this course, so we're just going to go ahead and click on this virtual machine option. And that's going to take us down just a little bit here. What you're going to do is you're going to download the respective version that you need. So if you need VMware, you download VMware. If you're using VirtualBox, go ahead and download the VirtualBox one. Now they have a direct download, which is a 7-zip, and they also have a torrent if you know how to torrent. What you're going to do is go ahead and download the file that you need. And while you're doing that, if you do choose to download directly, you're also going to need a tool called 7-zip or a way to unzip this file. So go ahead and start your download. While it's downloading, let's also go ahead and navigate to 7-zip. So if you go to Google and you look at 7-zip, you'll see this page here comes up. You just go to download. In here, you're going to download the file that is for your respective system. So here, I'm using Windows on 64-bit. I would download this executable right here. Now, if you're running on Linux, here's where you download Linux. If you're running on Mac OS, here's where you download for Mac OS. Very straightforward. I've already got this installed, but what you need to do is just download this and literally click next through it. Make sure you get it installed. Go ahead and pause the video. Once that is installed, 7-zip that is, and once you have the actual Kali image downloaded, go ahead and unpause the video. I'll be here waiting for you. Okay, so your next step should look something like this. you have your 7-zip file open. You should see a folder located in there. And the easiest thing is to just drag and drop this. You can also right click and extract if you know where you want to extract it. I created a folder called Kali. I'm just going to grab this and I'm going to drag it over. And it's going to take a minute here, just a few seconds honestly, to unzip. The file size of this one, at least for the VMware version, is around 11 gigabytes or 11 gigabytes exactly unzipped. So make sure you have the space on your hard drive in order to do this. Now, once you have it unzipped, you can go ahead and just double click in here. You'll see a bunch of files. If you have VMware installed, you can actually just double click on this VMX file and that should open things up for you. I'm just going to show you the other way around doing this as well. So with VMware Workstation Player open, what you're going to want to do is go to Open a Virtual Machine. And in the folder that you have, you should see this VMX file as well. Again, you could double click it or you could just open it through this. What's going to happen is it's going to open that file here and you're going to want to edit this virtual machine settings. Once you have it loaded, click on Edit Virtual Machine Settings. And in here, we're going to want to first change the amount of RAM that we have. Now, this is dependent on your system. If you have like 8 gigs of RAM or maybe even 16 gigs of RAM, you might want to try leaving it at 2 at first. I'm going to bump mine up to 4 gigs, which is 4096. And I have 128 gigs of RAM, so I have more than enough space to allocate for this. But if you're on like 8 gigs of RAM, probably not the best idea to jack this up beyond 2. Honestly, I would try it at 1, maybe 2, see how it works. The other thing you're going to want to make sure of is that you're running on NAT network. So if you click on network adapter, make sure that it says NAT and that's selected. Once that's selected, go ahead and hit OK. And then you're just going to hit play virtual machine. When it asks you what to do, just say I copied it. Now from here, it's going to take a minute for this to load. You can just let this run through. It'll boot on its own. Once you are presented with the login screen, go ahead and unpause the video. But until then, pause, and I'll meet you back when you're at the login screen. Okay, I'm at the login screen. I'm going to make this a little bit bigger just so we can see. And from here, what I'm going to do is I'm just going to type in the username of Kali, K-A-L-I, and the password of Kali, K-A-L-I. Hit enter. And if you see this screen, congratulations, you have successfully installed Kali Linux and you now have it up and running. In later videos, we're going to cover what we're going to be doing and how to use this and how to use Linux and all this. But for now, pat yourself on the back. You've got Linux installed, and we're going to pause here and move on to the next video. Okay, so this video pertains to some updates we need to make to VirtualBox for quality of life. So if you're not using VirtualBox, you can go ahead and skip this video. If you are, buckle in. We just need to do a couple of quick updates and then we should be good for the rest of the course. So go ahead and go out to Google and Google VirtualBox Extension Pack. What it's going to bring up is just the downloads page of VirtualBox. So we're going to want to go here. And on this page, if you look kind of towards the middle, you'll see that there is a VirtualBox extension pack here. We're going to just click all supported platforms and that will automatically download the file that we need. So once that is downloaded, and pause if you need to, go ahead and open VirtualBox. And you can come in here and up at the top, we're going to go ahead and click on Preferences. And from here, we are interested in extensions. See extensions right here. Go ahead and click on that. There's a little plus sign. We're going to go ahead and click on that. And then you should have your downloads right here. So we're going to take the downloads and just go ahead and install that. Hit install. Read this. Give away your firstborn. Accept all the terms. And you should be good. Very quick install. Okay. The second thing we need to do is we need to come to the one tab up here above, which is Network. We're going to go ahead and hit the Network button or this Add button, and we're going to add what is called a NAT network. Okay, and we're going to come in here and we're going to double click. And you can go ahead and keep these defaults. I'm going to actually change them to 192.168.57.0 because that's what's going to be used through the rest of the course. And that is what the CIDR notation of my Kali machine and my Keyoptrix, which you'll see later, etc., all